Today we're going to talk about Ohm's law. So what is Ohm's law? Well, Ohm's law is simply a relationship between voltage, current, and resistance in an electric circuit. This is one of the most fundamental formulas that we'll use in electronics electrical theory. It says that voltage is the product of current and resistance. Now, this relationship was first publicized by Mr. Ohm in 1827, but he was not the first one to actually discover the relationship. Mr. Cavendish actually found out about it decades before, but he didn't bother to tell anybody, so he doesn't get the credit. So that's why it's named Ohm's law. The formula is V is equal to IR. V, of course, is voltage, I is current, and R is resistance. And we use the SI base units of volts, amps, and ohms. However, this relationship also works if we measure current in milliamps and resistance in kiloohms. But again, if you choose milliamps as your current, then you must use kiloohms as your resistance. Otherwise, just go back to the base units of volts, amps, and ohms. Now, if you are an engineer, you use the function notation. So you have voltage is a function of time, V sub t, is equal to R, which is a constant, times I sub t. So that's the way the engineers would write it, but for us, we'll just stick with the algebraic version. And speaking of algebraic, we can have variations of Ohm's law. We can solve for I and get I is equal to V over R, or R is equal to V over I. Again, same units as we had before. So these are the same formula, it's just rearranged with some simple algebra. So you can either do that simple algebra or remember all three versions. Now, a closely related formula is referred to as the power formula, and that is power is equal to current times voltage. P is equal to IV. Power is measured in watts, current is measured in amps, and voltage is measured in volts. That's called the power formula. And just like Ohm's law has algebraic variations, so does the power formula. You can say voltage is equal to power divided by current, or current is equal to power divided by voltage. What's perhaps more important is combinations of these two laws, and the two formulas that are used most often that are a combination of Ohm's law and the power formula are power is equal to I squared R, that's current squared times resistance, or power is equal to V squared over R, voltage squared divided by resistance. Now, please understand that voltage and EMF are essentially the same thing. EMF stands for electromotive force, and we use the variable E. So you may see E or V used interchangeably in Ohm's law. They both have units of volts, and they are essentially the same thing, at least for a beginning student. So using E, Ohm's law would look like E is equal to IR, and the power formula, P is equal to I times E. So if you look at the AC version, what we looked at was the DC version, the most common version. The AC version is a simple variation of that where we take out the R and put Z there. Z is called the impedance, and impedance is both resistance and reactance combined into one term. So Z is the more general term. It includes R. So you may see Ohm's law written like this: V is equal to IZ, or E is equal to IZ. The E and the V really mean the same thing. So hope that gives you a short introduction of Ohm's law. I suggest you memorize the different formulas and variations of those formulas. You'll be using those a lot. For more on electrical theory, tune in to Mark's Tech Talk on YouTube. Thank you for watching.